Hey guys, welcome to part 2 of this week's videos. This is going to be your set of notes on our next section. So this one's going to be titled, it's number 38, and it's titled Vertex Form. Vertex Form. If you have any distractions going on, this is not a lesson to be distracted on. It's going to be one of the toughest ones I'm going to attempt to do in our, through these videos. So pay close attention. Number 38, vertex form. The good news about vertex form, and I'm going to put a 38 down here at the bottom corner. The good news about vertex form is you don't have to memorize that formula. It is in your reference materials on your formula chart. So I'm going to turn there right quick. There it is. Vertex form. We're going to copy that down. F of x equals a x minus h squared plus k. I'll write it again for you here. So f of x equals a times x minus h, close that and square it, plus k. So that's a lot of new looking stuff today. And I don't want to leave you confused about it at all. So one of the things that I'm going to use here in my notes is just a little piece of graph paper that we can kind of see what's going on. And I'm going to start you off with just some given values. I'm going to start you off with the a value being 1. I'm going to tell you that the h value is negative 3 and that the k value is positive 2. Okay, I think that's all I have to start you off with right now. And so all we're going to do is take those values and drop them in place here in place of a and h and k. A, h, and k. Alright, so f of x equals, the a value was 1 times x, and it says minus the h. So if I minus a negative 3, if I have h minus negative 3, that's a little bloop. So let's just go ahead and say x plus 3. Don't forget the exponent here of 2. And we're going to add the k value, which is also 2. Well, if you were faced with that right there and you had to solve it, where you're thinking, well, I don't know what to do, but actually there is some pathways for you to take. Well, this one's an understood one, so we really can just ignore it. 1 times anything will just be what that is. So x plus 3 squared means x plus 3 times itself, x plus 3. So let's write that out. So this is an understood one that I'll drop, but that means x plus 3 times itself, x plus 3. Let's split it out like that instead of writing it in exponential form. And let's don't forget the plus 2 here at the end. Well, if you think about it, you do know how to handle that. If we use the FOIL method, I have f of x equals, FOIL would be first times first, x times x squared. The outer, x times 3, is 3x. The inner, 3 times x, is another positive 3x. And then the last times the last, 3 times 3 is 9. And again, don't forget the plus 2. And then the only thing that I can see that can be done would be to combine the like terms. I have some x's here that are alike, so I have x squared equals, I don't have any other x squared, so I'll just pull it down. But I have 3 positive x squares and 3 more, so I really have 6 x's, 3x plus 3x. And then I can always add 9 and 2 and say plus 11. Plus 11. Now, all this is going to become a whole lot clearer if you can see it in a graph formation. And so one of the first things I want to do is on this little graph is I want to graph just the parent function. The parent function, if you'll remember, is f of x equals x squared. That's the parent function. If you looked at the lesson before, that was it. So if you'll recall, it's saying, turn it on, in x squared. If I go look at the table, remember it's just going to go through the origin. Whatever x is, you square it to get the corresponding y. So 0, 0 is a place it goes through. If x is 1, 1 squared is 1. So rise up 1. There's that bad pen again. 2 squared is 4. 3 squared is 9. If you want to get your own graph paper and kind of follow along with me in your notes, you can. Then I have that mirror image. And guys, all I'm doing some mental math on paper, but then the negatives are going to be negative 1, 1. Because negative 1 times itself is positive 1. If the x is negative 2, then its y coordinate to match it, if I square this, would be a positive 4. And of negative 3, it's going to be positive 9. So I'm just plotting these. If you have some graph paper, this would really be handy for you to do in your notes as well. So here's the parent function. I'm kind of breaking my rule and using pen rather than pencil, so I hope I don't do too badly. But I'm going to go ahead and draw through these ordered pairs. Remember, try to make these lines as smoothly as you can. Punch through those last points and put an arrow at each end. Some of y'all's quadratic drawing is pretty rough looking. So don't just go connect, connect, connect and make a bunch of straight lines, because then it's jiggy-jaggy looking. And just try to make a smooth, curvy line that goes through those points. Now that's the parent one, and I'm going to label that. This is the parent function right here. Well, let's graph this new one. And in our y equals form in our calculator, I can do that. So instead of just x squared, I'm going to type in x squared plus 6x plus 11. X squared plus 6x plus 11. Now, based on the lesson that we just covered, I now know it's going to cross the y-axis at 11. And because it's an upward opening parabola, because that's a positive x squared, so it'll open upward, then this is going to actually shift it to the left instead of to the right. So I'm going to hit graph. As a matter of fact, I'm going to put the parent function in there. It doesn't matter which one I type in first. So here comes the 6x squared, or x squared plus 6x plus 11, and there's the parent one. So yeah, it's crossing the y-axis up here at 11 now, and it did give it a leftward shift. So what I want to do is graph this one. I've already graphed the parent one. It's the one I have on there already. So this is the one I want to see. So if you don't want to have two sets of ordered pairs in your table, you can just take this one back out. And now when I go to look at the table, these are the ordered pairs. So 0, 11 is a point that I would have. I can't really fit that one on there because I actually went up to 8, 9, 10, 11. It'd be way up here at the very tip top. Then I have some others that should fit. That's way off the screen, but negative 1, 6. So negative 1, 6. Negative 2, 3. Negative 3, 2. And then let's see what happens above that. Oh, look, there's that mirror image stuff going on. Here's the 2, and there's a couple of 3s, and a couple of 6s, and there was that 11 that was down here. Let me make it visible again. So there it is. So this is the middle of things, and then everything begins to mirror image pair around it. So negative 4, 3. Starts going back up again. Negative 5, 6. And then negative 6, 11. Way up there at the tip top of my graph. Alright, so if I graph this one, and I'll use the purple pen. Let's see, negative 1, 6, negative 2, 3. I don't know what that point shouldn't be there. One like this. Let me get rid of that dude. I'm not sure why. I got there. That ordered pair was negative 2, 3. I just inadvertently drew 2 dots on that same line. So here this one is, arrows, arrows. So here's the new quadratic that came from this guy, x squared plus 6x plus 11, which we know is equivalent to this guy up here. But this one's in vertex form, and this is in standard form, right? F of x equals ax squared plus bx plus c. So what you have is two equations, but they're the very same. One's just in vertex form and one's in standard form. I'm just going to write this, standard. And this one's in vertex form, after you drop the values in. Just values that I gave you. Vertex form, standard form. Okay, but let's take some note of this. Notice that the vertex here was at 0, 0. Since this is called vertex form, then let's pay attention to the vertex. The vertex right here is at -3, +2. -3, +2. Now, those numbers should look familiar to me because earlier in this given information, I told you that the h value was -3 and that the k value was +2. Do you see how it matches up? That's important to take note of, and one of the main reasons I even went through this process was to show you that the vertex is found in the vertex form right here in the place of h and k. So right here I'm just going to write h, comma, k. If you are handed the vertex, then you are handed the h coordinate and the k coordinate. All right, so here's how we're going to move along with this. Let's write the vertex form one more time. Skip a few lines and let's write f of x equals a parentheses x minus h squared plus k. That's just the copy again of the blank one without any numbers dropped in. And just like we did earlier with the standard form, we talked about what a and what all these values do. Remember, f of x is the same thing as just y, and x is just x. Those are just an x and y coordinates somewhere along this parabola. The a value, once again, affects the slope. The words that they use here is that they dilate it. Remember that it can be a compression or a stretch. The h value controls the horizontal shift. And the k value controls the vertical shift. All right, so outside the notes, what you're going to be required to do is if I give you an equation, you have to write the equation if I give you the vertex and 1 point. So let's see what that looks like. Let's go to the next page because you'll need quite a bit of space for this. All right, we're still in vertex form, and this is example 1. You're going to have 4 problems on your assignment that look a whole lot like this, so be sure to pay attention. So what I'm going to provide for you as given information is I'm going to tell you that the vertex is at the ordered pair 2, 4. And then I'm just going to provide just some other rando ordered pair somewhere along the parabola. And I'm just going to say, and a point found at 3, 6. So if you want to kind of write, well, what are we doing with this? You're going to write the equation. If you're given the vertex and 1 point. And that's what I've given you, the vertex and 1 point. So one of the clearest things I would say to do is let's once again write that vertex formula. F of x equals a parentheses h minus, it's x minus h, x minus h squared plus k. Now think about what we have up here. If this is the vertex, remember this is the h and this is the k coordinate. And if this is just some random point, then this is just some generic x and y value along that parabola somewhere. So now I have an h, a k, an x, and a y, which means I can replace them in all of these places. So the h is 2, so here in place of the h, I'm going to write, let's just start left to right. F of x is the same thing as y. Our y value is 6. So 6 equals. Up here I don't have an a value, so I don't know it. I'm going to just leave it in a. Just leave the a. The x coordinate parentheses, and then the x coordinate is 3. And I'm supposed to be minusing the h value, which is 2. Don't forget we got to square it. And then we're going to add the k value, so plus 4. Alright, now we're just going to begin to solve everything that we can solve. So I have 6 equals a times, and then inside the parentheses, 3 minus 2 is 1 squared plus 4. So 6 equals a times 1 plus 4. A times 1 is simply a plus 4. And all I can really do here is to solve for a. So you might want to make a side note over here. We're going to solve for a. Solve for the a value. That's what we're doing in this section. So to get a by itself, we're going to have to come in and minus 4 from both sides. And when we do, we'll find that the a value is 2. The a value is 2. Well, I'm not done, but now I have everything. If you'll notice that in the vertex form of an equation, back at this sample that we worked the first time I gave you one, we plugged in the a value, the h value, and the k value. And that's what we're going to do now. I've provided you to start with the h and the k, and we found by our own work the a value. So the h is 2, the a was also 2, and the k was 4. So the a was 2, we had to calculate that one right here. And then up here at the beginning, I gave you the h and the k value when I specified and told you that this was the vertex. Then I gave you the h and the k value. So now we're just going to drop these 3 values into that parent formula. So I'm going to leave it f of x equals, now I know the a value is 2, parentheses. I'm not going to replace x. I want to keep x and y kind of open to generically find any point along this parabola. We're going to minus the h value, so we're going to minus the 2 here, square it, and add our k value, so plus 4. Ta-da! You have written an equation in vertex form. In vertex form, you have written the equation of a line that has this as its vertex and passes through the point 3, 6. I'd like to say that's the end of it, but one thing that you have to do at this point forward is to be able to take that and also convert it back to standard form. If you think about it, you've already done it. On the very first page, when I started these notes with you, I handed you in vertex form. We spread out that and worked it out and put it in standard form. So we've already done that. But let's go ahead and now put this one in standard form. So that's the answer in vertex form. Let's put it in standard form. So this means f of x equals 2 times, and I'm just going to, instead of writing this in exponential form, I'm just going to write this x minus 2 times itself, but I'm going to set it side by side, x minus 2 times x minus 2. Remember, it's going to write it in expanded form rather than vertex form. Plus 4. So f of x equals, I'll leave the 2 right now. I'm going to focus on the full method. X times x is x squared. The outer would be a negative 2x. The inner is also a negative 2x. And then the last is a positive 4, because negative 2 times negative 2 is positive 4. And then this is a separate positive 4. It gets drawn down also. But now hang on, this stopped right there. So this is the first, outer, inner, last products of this binomial times this binomial. So now I'm going to have to times all of this by 2, because it's all was multiplied by this a value. Okay, so let's do that. When I have f of x equals 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. Again, another negative 4x. And then 2 times 4 is 8, positive 8. And then I can bring down this last little rear end plus 4. Now all I'm left to do is combine these like terms here and here. So f of x equals 2x squared. It's the only one of its type. That's the only x squares there are. But a negative 4x and a negative 4x would make a negative 8x. And a positive 8 and a positive 4 would combine to make a positive 12. So there is the very same answer, but in standard form. Vertex form and standard form. So there's a lot of work involved. It takes some space to do each one of these. I'm going to give you an assignment. It's just called Vertex form. It's something that I came up with. It's going to look like this right here. Since there's only 4, I'm not going to work one with you, but I did provide a lot of space. If that does not seem like it's adequate space, then feel free to work this on notebook paper. And again, if you will, just take pictures of your work and send it to me. If you will, attach it in your Google Classroom there. I'm having to look at about 4 different places to try to find people's homework. Some folks are texting it to me. Some are sending it in an email to me. Some are sending it through Google Classroom, and some are sending it in through paper form. So I'm having to kind of really scatter around to try to gather everybody's work up. If it's possible for you, please, please, please just attach your pictures into the Google Classroom. If you don't know how to attach a picture in Google Classroom to the assignment, ask somebody. I know Hayes, give them a little tutorial. I noticed that you were able to do that. So guys, that's it for the day. You know that there's only gonna be 4 problems on your assignment. So take your time, get them right, because they'll have to count off a good bit many points apiece. So be sure to show all of your work. Call me if you need me. Love you. Bye.